So we are going to be solving chemistry paper 4 theory extended October-November 2023 paper 42 today, and this is going to be a difficult paper. So let's get started by reading question number 1, which says table 1.1 gives the electronic configurations of some atoms and ions from A to G. ठीक है, some are atoms and some are ions. ठीक है, the atom, these words are very important. Atoms tell us that they haven't lost or gained any electrons, and ions tells us that either they have lost electrons or either they have gained electrons. ठीक है, so that's the difference. अच्छा, let's first look at the table and try to predict as many things as we can before reading the question further. अच्छा, 5 electronic configuration means that firstly we have two shells. ठीक है, the numbers in this has 3 numbers, this has 3 numbers, this has 3 numbers, this has 3 numbers, this has 4 numbers. These numbers tell us that how many shells does that atom or ion has. ठीक है, if it's 2, 8, 18, 7, that means that in first shell it's 2, then in second shell it's 8, then in third shell it's 18, and then in the fourth shell it's 7. ठीक है, so basically these are telling you about the shells. ठीक है, how many shells does that atom or ion have? First thing that the table is telling you. Second thing that the table you can infer from the table is that the number of electrons in the valence shell. This atom particularly, or ion, this cannot be an ion because it has 5 electrons in the valence shell. If it was an ion, it would have 8 electrons or 2 electrons in the first shell, but in the second shell it would have 8 electrons, meaning full second shell, because ions have the the electronic configuration of a noble gas. After losing or gaining electrons, they get full outer shell electrons. So basically this atom which we are talking about right here, this atom, what I was telling you, is gonna be in group 5 of the periodic table. Okay, the second thing we can tell from this table is the group number. If it's an atom, not for an ion, for an atom we can tell the group number. This is going to be in group 2 because it has 2 electrons in its outermost shell. This is going to be in group 4. This is going to be in group 5, this is going to be in group 6, and this is going to be in group 7. So these last number tells us about the group number, and the total numbers, the 2, 8, 18, 7 tells us about the period number, how many shells that particular atom is going to have. So let's get started with reading the question. Okay, answer each of the following questions about A to G. Each letter may be used once, more than once, or not at all. State which of the atoms or ions from A to G could be a noble gas atom. Okay, when we're talking about noble gas atom, the thing that comes into our mind, the first thing should be that it should be stable and it should have full outer electrons, full outer shell electrons, meaning the outer shell should be outer shells should be filled with electrons. ठीक है, should be filled. It should have, if it's the second shell, it should have complete 8, and if it's the first shell, it should have complete 2. Just say, for example, if I talk about helium, helium is a noble gas, and helium does not have 8 electrons. Helium only has 1 shell, and there are 2 electrons in it. So for helium, it's a noble gas with 2 electrons in its outermost shell. So it's wrong to say that noble gas have only 8 electrons, because helium is also a noble gas. So the thing over here is that you need to remember is that whatever shell is it, either it's the first shell or the second shell, it is on its full capacity, meaning it has full electrons which it can hold. ठीक है, noble gas atom है, so it's gonna obviously have either this 8 part, or do we have another 8? No, we have only this one. So it has to be B. So we're going to write B over here. ठीक है, an atom of an element in group, this one is 5, and there's a 1 after it, that means +1, group 6 of the periodic table. ठीक है, when we're talking about group 6 of the periodic table, we should know that group 6 means that last shell should have 6 electrons, and only this F has 6 electrons in its last shell, so it has to be F. ठीक है, an atom with an atomic number of 14. ठीक है, atomic number is basically your proton number. ठीक है, atomic number is your proton number, and you should know that in an atom the proton number equals to the number of electrons. So the proton number and the electron number are equal. So for the electronic configuration, we should have an atom that has a total of at least not at least a total of 14 electrons we need, because proton atomic number 14 means 14 protons, and if it's an atom it's going to have 14 electrons for sure as well. So we got to calculate. This is going to have 5 6 7 total electrons. This is going to have 10. This is going to have 10 11 12, and this one right over here, D, is going to have 14. If you calculate it out, 8 plus 2 plus 4 is going to be 14. So the answer is D. How do I know D? Because I simply knew that the number of protons and electrons in an atom are equal. Atoms from the same group. Same group means that same number of electrons in valence shell. You should know that all the atoms in one group have same number of electrons in their valence shell or the last shell. Okay, if you're talking about halogens, group 7, all fluorine, chlorine, bromine, iodine, and astatine, all of them are gonna have one electron. Not one electron, they're going to gain one electron. All of them are going to have 7 electrons in their valence shell. So the number of electrons all the atoms have in the valence shell in one group is the same. If you take group 1, all of them are going to have 1 electron. If you take group 7, all will have 7. If you take group 5, all will have group 5. So if they're talking about the same group, it's probably going to be the atoms with the same number in their last shell. Okay, we figured it out. A also have 5 electrons in the last shell, and E also has 5 electrons in the last shell. So it's going to be A and E, which are going to belong to the same group because they have the same number of electrons in the last shell. So atoms from the same group are A and E. Acha, a halogen atom. Halogen basically means group 7. Okay? Group 7. So that means it's going to have 7 electrons in its valence shell, and this one G is the halogen because it has the 7 at its end. So we're going to write G over here. Okay? An atom of an element which is a good conductor of electricity. Achha, when we're talking about electrical conductivity, first of all we need an atom, and second thing is a good conductor would mean that it's a metal. Okay? We should know that non-metals are not good conductors. So an atom which is a good conductor has to be a metal atom, and we should know that metal, either it's going to be a group 1 or group 2, or it can be the transition metals, but it cannot be like this is a halogen, so this cannot be a good conductor. So if we need a good this also in group 6, that's a non-metal. If we need a good conductor, we got to take something that's this one right here is a metal because it has 2 electrons in its valence shell, so it belongs to group 2, and group 2 is a group that has metals. Okay? On the right side, on the left side of the periodic table, your left side hai, this is the right side of the periodic table. On this side basically you have metals, on this side you have non-metals. Over here you have group 1, group 2, these are all metallic groups. Okay? And then you have the transition metals, then you have the metalloids over here, and then you have non-metals right here. So this is going to be C. C is going to be a good conductor. Why? Because it's in group 2. So an atom of an element which is a good conductor is going to be C. Achha, a stable ion of a group V element. Achha. Now this might seem a bit confusing, but what they're talking about here is group 5 might confuse you and make you think that it's going to be either this A or this E with 5 electrons in the valence shell. But what they're talking about is not the atom. They're talking about a stable ion. A stable ion means that it has stable, BLE. Ion means that it has full outer electrons, full outer shell electrons. Okay? Full outer shell electrons. Iska matlab hai the last shell should have 8 electrons because it's a stable ion. It has either gained or loosed electrons, whatever it has done to stabilize itself, means obtain the electronic configuration of a noble gas. So it should have 8 electrons. So what does have 8? This right here, B is going to be the answer. so it has to be B. Why it has to be B? Because it's an ion. If it was an element from group 5, you could have taken A or E, but it's an ion. Acha. An atom that forms an ion with a charge of 2 negative. Acha, अब वो एक atom की बात कर रहे हैं. Now they're not talking about an ion, they're talking about an atom. Obviously 2 negative means you need to gain 2 electrons. ठीक है? 2 negative means gain 2 electrons. And what kind of atom would gain 2 electrons? Obviously, देखें, एक atom needs to have total of 8 electrons in its outermost shell. Obviously, an atom which will have 6 electrons will obviously try to gain 2 more electrons to get 8 now. So, and then it will gain a charge of 2 negative. So obviously an atom that has 6 electrons will try its best कि वो 2 gain करके 8 पे आ जाए. So that's going to be an atom with 6 electrons in its valence shell, and that is this F right here. So we're done with the first question. Let's move on. Cobalt and copper are transition elements. ठीक है? Copper has 2 naturally occurring isotopes, copper 63 and copper 65. Cobalt has only 1 naturally occurring isotope, cobalt 59. Now these isotopes, the numbers on the top, they are basically the mass numbers. That's why they're different. In isotopes, you have different mass numbers, but you have the same number of proton. Proton number same होता है, but देखें 63 है, मतलब इसमें इसके nucleus में the total of protons and neutrons is 63, and the nucleus of this, the total of protons and neutrons is 65. So these are the mass numbers which are different for isotopes. अच्छा, copper के 2 isotopes हैं. Cobalt has 1 naturally occurring isotope. Complete table 2.1 to show the number of protons, the number of neutrons, and the number of electrons in cobalt 59 and an atom, cobalt 59 atom, and copper 65 2+ ion. अच्छा, अब ion में there has to be some differences. Let's figure it out and fill the table. अच्छा, सबसे पहले proton number. Cobalt में we're going to check it out from the periodic table. And for copper as well, the proton number for ions are going to remain the same. Ions में electrons are lost or gained, but the number of protons remains unchanged. ठीक है? So for proton, let's go to the periodic table and check out for copper and cobalt. Where is copper? This is cobalt, and this above is basically the proton number. For cobalt, it's 27, and for copper, it's 29. To get 27 and 29. Okay, let's fill our table. For cobalt, it was 27. For copper, it was 29. Neutrons is basically, this is your mass number. You subtract the proton number from it to get the neutron number. So it will be 59 minus 27, and you're going to get the number of neutrons. So 59 minus 27 is going to give you 32 neutrons for cobalt, and 65 for this. We are going to take 65 minus 29 will give you 36 neutrons for copper. Acha, the next thing you got to figure out is the electrons. Acha, in an atom, we have taken cobalt atom over here. In an atom, the number of protons equal to the number of electrons. ठीक है? तो जितने इसके protons हैं, which are 27, the electron number is going to be the same. It's going to be 27 as well. So we write it 27 over here. But now when it comes to ions, there's going to be a difference in the number of protons and electrons. You should know that ions, they have charges because they have different number of protons and electrons. Asha, now the thing over here to be noticed is copper has a charge of 2+ on it. A charge of 2+ means that 2 less electrons. ठीक है? A charge of 2+ means 2 less electrons. Basically, if you had a charge of 2 negative, that would mean 2 more electrons, but 2+ means 2 less electrons. So if the proton number is 29, the electron number is going to be -2. You have 2 less electrons than protons, giving you a charge of 2+. So 29 minus 2 is going to give you 27 right here. Okay? So for ions, be careful about the charge in calculating the number of electrons. Okay, let's move on. Table 2.2 2 shows the relative abundances of the two naturally occurring isotopes of copper. This is the isotope, this is the relative abundance. Calculate the relative atomic mass of copper to 1 decimal place. Acha. For the formula for that's very simple. Acha, first thing you do is you write the percentage. That's going to be 70 of the first isotope, 70 upon 100. And then you multiply the percentage with the mass, which is 63 for this copper, okay? And then you add these both. This, now you write the percentage for the second copper, which is 30 upon 100, into the mass of the second copper, which is 65. And now you just solve it on your calculator and get your answer, and the answer you're going to get is 63.6. So the relative atomic mass to 1 decimal place is 63.6. Okay, let's move on. That's simple, that's very simple. You just need to write the percentage and multiply it with the mass number. Acha. One physical property of a transition element such as copper and cobalt is that they're hard. Okay, that's the physical property they have told us. Other metals such as lithium are softer. State 2 other physical properties of copper and cobalt which are significantly different from lithium. Asha, now you should know that copper and cobalt are basically your transition elements and lithium is basically your group 1 element. So what they're asking about is the differences between transition elements and group 1 elements. And what they're asking about is the physical differences. ठीक है, chemical differences में आप लिखते catalyst, variable oxidation state. Again, they would have asked for the differences in the chemical properties. You could have written variable oxidation state, catalysts, and colored compounds. But for physical properties, even if you check the marking scheme for this question, for physical properties, it's about high melting and boiling points, it's about the densities, it's about the hardness. Achha, physical properties both हैं which you can see. Okay? So for physical properties, you don't write variable oxidation state, catalyst, and colored. You write about the densities, about the melting and boiling points. Okay? So now let's write about the two differences. Achha, the first difference is going to be obviously lithium group 1 में group 1 metals जो होते हैं they melt at a lower melting point, and the copper and cobalt, which are transition elements, are gonna have a high melting and boiling point. So the first difference is gonna be copper and cobalt have the physical differences. Okay, we're talking about the physical differences, the properties, differences in the physical properties. Copper and cobalt have high melting and boiling point. That's going to be the first difference, whereas your lithium has low melting and boiling point. The second difference is going to be that copper and cobalt have high densities, whereas your lithium has a low density, because group 1 metals have low densities, group 1 metals have low melting and boiling points, and they're soft as well. Achha, let's move on to the next question, which says both copper and cobalt can form colored compounds. Okay, that's a property of transition elements. Some of these compounds contain water crystallization, defining the term water crystallization. The exact definition of water crystallization is mentioned in the syllabus. Learn it from the syllabus. The water crystallization is basically water molecules, when water molecules are present in hydrated crystals. Okay, water molecules present, this is exactly present. Acha, जब भी define आते ना, you have to write down the definitions from the syllabus, learn them from the syllabus. Water molecules present in hydrated crystals. Acha, and now I would like to tell you one more thing. कि देखें, copper and cobalt, they're basically used to test for water. How they're used to test for water? देखें, simple copper sulfate is white in color, simple powder. Okay, simple powder copper sulfate is white in color, but when you add water to it, okay, it basically turns blue in color. Okay, it turns blue in color. So it is used to test for water. And basically the crystals of hydrated copper sulfate are CuSO4.5H2O. So this 5H2 is basically the water of crystallization. These are blue crystals, ठीक है? ये blue crystals होते हैं. So this is the water of crystallization that's chemically combined with the salt, ठीक है? So that you should know. And for copper chloride as well, cobalt chloride as well, COCl2, not copper, cobalt chloride 0.6H2O. So basically this is the water of crystallization, ठीक है? Water of crystallization. And this water of crystallization basically is, and these are pink in color, ठीक है? It makes it colorful, ठीक है? वैसे it is blue, but when you have water crystallization it turns pink. अच्छा, state the color and the formula of hydrated copper cobalt 2 chloride crystal. अच्छा, formula we just did right now, it was CO cobalt chloride 0.6H2O. अच्छा, learn these two formulas for copper sulfate as well because they're part from syllabus. And the color is going to be pink. Why pink? देखिए, anhydrous का blue होता है और hydrated का pink होता है. Learn it from the syllabus. These are, things that are cramming based, ठीक है? You got to learn them. State the color change seen when a few drops of water are added to anhydrous copper sulfate. अच्छा, again, it's same. Anhydrous copper sulfate is white in color, and when you add water to it, it turns blue in color, ठीक है? State how this color change is reversed. Simply देखें, अगर वाटर ऐड करने से वो वाइट से ब्लू हो रहे हैं एंड यू वांट टू रिवर्स इट, यू रिमूव द वाटर, ठीक है? अगर वाटर ऐड करने से दे आर टर्निंग फ्रॉम वाइट टू ब्लू, इफ़ यू वांट टू रिवर्स इट, यू वांट टू टर्न फ्रॉम ब्लू टू वाइट, you want to remove water. What do you do to remove water from anything? You heat it. So the answer is going to be heat the copper 2 sulfate crystals, and you're going to remove the water and you're going to reverse the process. Okay, iron is manufactured in the blast furnace. 3 of the starting materials are added to the blast furnace: coke, iron ore, and limestone. Name the other starting material added to the blast furnace. Acha. Now, important thing over here is that these are the 3 main core ingredients, or you can say core, kind of the more integral part of a blast furnace, which you got to add into the blast furnace in order to get your iron, which is coke, iron ore, which is hematite, and limestone. And now they're asking for one other starting material. Achha. So this might be a little bit confusing because these are the 3 main, but you should know that we also pump some hot air, ठीक है, from below. This is basically a blast furnace. You pump some hot air from below, so it's going to be hot air. Why do you pump it? Because from air you have a lot of things. Basically it adds basically carbon dioxide from there, you need oxygen from there, and there are a lot of gases. So hot air is pumped to maintain the temperatures as well. In the blast furnace you got to maintain the temperature, and basically the other gases which are not used, like देखिए oxygen जो होती है वो भी react करती है ना, it has to react in the blast furnace. Oxygen has to react in the blast furnace. Asha. Oxygen also has to react in the blast furnace, so you got to pump in hot air as well. You need to maintain temperatures. और जो waste gases होती हैं जैसे nitrogen जो हमें नहीं चाहिए होता, argon होता है, they all come out from the top. So it's going to be hot air because you need oxygen from there as well, ठीक है, for the reaction of carbon with oxygen to form carbon dioxide. अच्छा. The source of iron in the blast furnace is found in iron ore. ठीक है, name the main ore of iron which contains this. Obviously the ore of iron is hematite. The ore of aluminum is bauxite. Learn it. ठीक है, the iron is Fe2O3 is reduced by the reaction with carbon monoxide. The unbalanced equation is shown. Complete the equation. ठीक है. Now I don't even have to look at it. This is such a commonly repeated question that you should learn the balancing. You take 2Fe you take 3 carbon monoxide, you take 3 carbon dioxide. Okay, learn this. State the change in oxidation number of iron in the reaction in this thing. The change in oxidation number over here, we know that because this is element, ठीक है, यहाँ पे elemental form में, so the oxidation number is going to be 0. You know, in elements the oxidation number is always 0. But over here, देखें ये जो oxygen के नीचे 3 लिखा है, this is basically the oxidation number of iron, which is 3 plus, और जो iron के नीचे 2 लिखा है, this is the oxidation number of oxygen, which is 2 negative. So for Fe2O3, iron is going to have an oxidation number of 3 plus. How do I know it? Because the oxidation number of not the oxidation number of oxygen, the number written below oxygen is basically coming from the iron, and this 2 over here was the oxidation number of oxygen. So from 3 plus it's going to 0. So from 3 plus to 0. This 3 plus is important, okay? You got to write 3 plus. If you write simple 3, marks are going to be deducted. Achha. Explain how the change of oxidation number shows that iron has been reduced. The oxidation number is simply reducing from 3 plus to 0. That's a reduced, okay? So we're going to write that oxidation number is decreasing. Achha, whenever your oxidation number is decreasing, that's reduction. And whenever your oxidation number, अच्छा अगर यही वो 0 से 3 plus पे गया होता, तो फिर that was oxidation. Why? Because oxidation is an increase in oxidation. अच्छा, learn all the definitions क्या है? Oxidation is an increase in oxidation number. Oxidation is loss of electrons. Oxidation is gain of oxygen. And oxidation is loss of hydrogen. ये 4 definitions है, learn कर लें. और reduction जो होती है, decrease, reduction is basically your decrease in oxidation number. It's your gain of electrons, it is your loss of oxygen and gain of hydrogen. ये 4 definitions आनी चाहिए, ठीक है? So basically these hydrogen वाली इतनी ज़्यादा tested नहीं होती, लेकिन बाकी वाली loss of electrons और oxidation number वाली they're more tested, ठीक है? Let's move on. The major impurity in iron ore, silicon ivy oxide, limestone is added to the blast furnace to remove this impurity. Write down the 2 simple equations to show how silicon ivy oxide is removed from. For each equation, state the type of the chemical reaction that takes place. Achha, equation 1. Achha, now what we're talking about is basically how limestone is used to remove silicon ivy oxide, which is basically your sand. Silicon ivy oxide is the structure of the sand. It's an impurity and we need to remove it. Achha, sabse pehle to we take limestone, which is calcium carbonate, CaCO3, and we thermally decompose it. Okay, so equation 1 is going to be your calcium carbonate, which you've added, which is your limestone, and you thermally decompose it, meaning you heat it to form calcium oxide. Achha, ye equations of the blast furnace, you should learn them by heart. They're quite often tested. Plus carbon dioxide. And the type of chemical reaction, because you've thermally decomposed it, it's going to be a reaction which is going to be called thermal decomposition. Asha, ठीक है, the second thing is going to be, now this calcium oxide which you formed is going to react with your silicon oxide to form slag, and slag is going to be removed. That's how you remove silicon oxide, the impurity. So now what you do is, this calcium oxide formed is going to react with SiO2 to form calcium silicate. This is your slag, and the scientific name or the chemical name for it is calcium silicate. The type of chemical reaction this is, देखें ये हमारा जो है calcium oxide, because it's a metallic oxide, calcium is a metal, it is a basic oxide, ठीक है? Metallic oxides are basic, and silicon is basically your non-metal, so this is a non-metallic oxide. So silicon ivy oxide is your acidic oxide, and between basic oxide and acidic oxide is going to be an acid base reaction, ठीक है? अब ये neutralization reaction क्यों नहीं है? You might think ये तो neutralization reaction reaction इसलिए नहीं है. Even if you check in the marking scheme, it's clearly stated this is an acid base reaction. This is not a neutralization reaction, because always remember, in the neutralization reaction, always you're going to have a salt formed plus water. न्यूट्रलाइजेशन रिएक्शंस में हमेशा सॉल्ट और वाटर फॉर्म होता है, ठीक है. इवन इफ any other product, like अगर कार्बन डाइऑक्साइड भी फॉर्म हुआ है ना, तो दैट्स नॉट अ न्यूट्रलाइजेशन रिएक्शन, दैट्स एन एसिड बेस्ड रिएक्शन, ठीक है. सो this is not a neutralization reaction. In the marking scheme as well, it's clearly stated it's not neutralization, it's acid base, ठीक है. Don't forget this thing. So write acid base reaction, because this one is your base, this one is your acidic oxide, ठीक है. Let's move on. Iron is converted to steel by mixing it with carbon and other elements, ठीक है. That's basically forming an alloy of iron. State the term given to a substance which is a mixture of a metal and other metals. That's simple and easy. Those are alloys. Alloys are basically a mixture of metals. Name one element other than carbon mixed with iron in the making of stainless steel. अच्छा, अब stainless steel में it's clearly stated in the syllabus. The metals you're using for stainless steel are iron, carbon, chromium. Just learn it from the syllabus, and nickel. So for this, they've stated other than carbon and iron that are mixed with iron. So it's going to be either chromium or nickel. Learn it from the syllabus. It is stated in the syllabus. Okay, chromium, or you can write nickel. Write any one of them. Acha. Preventing the rusting of steel is important. State the chemical name of rust. Rust is basically when your oxygen in the air and water react with your iron, ठीक है. So when water will react with the iron, it will hydrate it, ठीक है. Water becomes chemically combined with your iron, so it becomes hydrated iron 3 oxide. Remember, rust is your iron 3 oxide and it's hydrated, ठीक है. So it's hydrated iron 3 oxide. If you don't write any one of it, hydrated you don't write, you're not going to get the mark, because water is being added to it. Rust is basically formed because of water and oxygen being added to this iron. So that's going to be iron, hydrated iron 3 oxide. Let's move on. Steel can be coated with zinc to prevent rusting. This provides both barrier method and sacrificial protection. State the term used for coating steel with zinc. That's going to be obviously when you coat iron with zinc, that is called galvanizing. ठीक है. Describe another barrier method to prevent rusting. अच्छा, barrier method means that it does not mean sacrificial protection. अच्छा, sacrificial protection में you would use a more reactive metal like zinc, ठीक है, or you can use magnesium, which is more reactive than iron. But what you do in a barrier method is basically you coat your iron, ठीक है. If this is your iron, you coat it with something, ठीक है, anything. It can be plastic, it can be grease, or it can be paint, ठीक है, anything. You coat it. This green layer is your coat, and basically what this coating does is it prevents the oxygen and water vapors in the air to reach the surface. Red is the surface of the iron, to reach the surface of the iron, ठीक है. इस coating की वजह से the oxygen and the water vapors in the air are unable to reach the surface. Hence, you get protection. So you can either grease it, you can either paint it, or you can cover it with plastic. So a barrier method can be greasing, it can be painting, or coating with plastic. Plastic is also going to stop the exposure of air and water. Coating with plastic. Asha, explain how zinc provides sacrificial protection. Asha, now the thing over here that is to be known is that basically this is your iron and this is your zinc. Okay, basically zinc is grey, but I was just drawing it with pink. Asha, what zinc does is that zinc is more reactive. Okay, zinc is more reactive than iron. So zinc forms electrons more readily than iron. Okay, you should know that higher you are in the reactivity series, potassium, sodium, and then there's some other metals, then there's zinc, and then there is iron. Asha. Now basically zinc is above iron in the reactivity series. Okay? It is more reactive than iron. So zinc will form positive ions more readily than iron. Okay? Zinc will form positive ions more readily than iron. Hence, zinc reacts with the oxygen and water instead of iron. Okay? Instead of iron combining with the oxygen water to form rust, zinc will combine with oxygen water because it forms positive ions more readily. So we're going to write that zinc is more reactive than iron, hence it reacts or corrodes in preference to iron. These 2 marks, first mark is going to be for zinc is more reactive than iron, okay? And second mark is going to be for that it reacts or corrodes in preference to iron or instead of iron, okay? So you got to write both 2 points in order to get the 2 marks. Achha. Let's move on to next question. This question is about lead chloride. A student prepares a sample of insoluble lead chloride PbCl2 by mixing aqueous solutions of 2 salts in a beaker. Okay? Identify the 2 soluble salts suitable for making lead chloride when mixed together. Asha, they've told us that lead chloride is basically an insoluble salt, and you should know that whenever we're preparing insoluble salts, we take 2 soluble salts. Soluble plus soluble will form an insoluble salt. Okay, you should know this. We take 2 soluble salts and insoluble salt. Actually, the insoluble salt to be prepared is lead Pb and Cl2, lead chloride. अच्छा, इसका मतलब है we need lead ions and we need chloride ions. हमें 2 ऐसे soluble salt चाहिए in which we have lead ions and chloride ions. I know all nitrates are soluble, so I can take my lead nitrate because lead nitrate is going to be soluble, and I can take my sodium chloride NaCl, which is going to be soluble. Both are soluble, sodium chloride and lead nitrate, to form my insoluble PbCl2. So what 2 salts am I going to take are sodium chloride and lead nitrate. Okay, done with it. Write the ionic equation for the formation of lead 2 chloride by mixing aqueous solutions. Asha, the ionic equation is simple. Asha, ionic equation mein you don't have to write everything, you just have to write the ions. They're going to be the lead, include the state symbols. That's important. Asha. For ionic equation, you don't have to write the complete sodium chloride, you don't have to write the complete lead nitrate. आपने सिर्फ वो चीज़ें लिखनी होती हैं which are basically reacting and forming the insoluble product. For that, I guess you should learn that method in which you cancel out the same ions on both sides. Okay? So what we're going to do is we're going to take lead ions. Since we've taken lead nitrate, it's going to be soluble, we write aqueous. Plus we're going to take chloride ions, you write negative on it, and since we have taken sodium chloride, so they are also going to be aqueous, and these are the state symbols we're including. And then what we're going to form is we're going to form lead chloride, and this is insoluble, so you can write S or you can write PPT, which means a precipitate. And since you have 2 chlorides over here, you're going to add a 2 over here, and you're done with your entire ionic half equation, and you're going to gain 3 marks for this. 1 mark is going to be for the product, 1 mark is going to be for the state symbols, 1 mark is going to be for the balancing. Okay? And everything is important. Okay? Now let's move on to the next question, which says that list the steps the student take in preparing pure sample of lead 2 chloride from the mixture in the beaker. Now the mixture in the beaker, basically it contains your lead chloride, which is insoluble. Okay? Now you have insoluble, so simple, you just are going to take a filter paper, you're going to filter it out. The residue on the filter paper is basically your lead chloride. You're simply going to wash it, and then you can dry it between sheets of filter paper. So the first step is going to be filtration. Okay, filter out PbCl2 precipitates. Second step is going to be wash the residue. Residue is going to be basically your PbCl2 precipitates, which are going to be the lead chloride precipitates. Wash the residue with distilled water. Basically, you wash it to remove any soluble impurities on it. And the last step is going to be dry between sheets of filter paper. Okay, and you are done gaining your 3 marks. Okay, 1 mark for this, 1 mark for this, and 1 mark for this. Let's move on. Acha, a student carries out an electrolysis experiment on molten. Acha, you got to be sure about what kind of electrolyte you're using. It's molten lead chloride. Using the apparatus shown in figure 4.1, chlorine gas forms at the anode and escapes from the apparatus. Okay. Now, you're not given with the anode or the cathode. You're simply given with the 2 electrodes. And what's happening is this is your power supply. You simply set up an electrolysis experiment in a test tube. You've added this bunk to it, and then you've just taken molten lead chloride and started with providing it with electricity and basically decomposed. Obviously, you've taken molten lead chloride, so what's going to form? Your lead and chlorine gas. Okay? It's molten. There are no water molecules in it. No water ions, no hydrogen or hydroxide ions, so no hydrogen or oxygen can be formed. Okay, explain why lead chloride needs to be molten before it conducts electricity. Actually, solid में the lead ions and chloride ions are going to be stagnant or stationary, or you can say fixed positions. So in molten, they're going to be mobile ions. They can move. So you can write free mobile ions in molten lead chloride. Okay, and these mobile ions can basically conduct the electricity. Achha, write the ionic half equation for the reaction occurring at the anode. Anode pe what are we forming? अब हमारे पास lead है और chlorine है. So obviously at the anode we form the anion, which is the negative ion. So the ionic half equation is you can have chloride ions, and then you're going to form chlorine gas from it, plus 2 electrons are going to move out of it, and basically to balance it out you write it over here. That's going to be ionic half equation for the anode. State the test for chlorine gas. Chlorine is a strong bleaching agent, so the test is basically you take a damp litmus paper, and because it's a strong bleaching agent, the observation is going to be it bleaches away, it bleaches or turns white. Achha, bleach means that the color fades away, so turns white. Okay, that's going to be your observation because chlorine is a strong bleaching agent. Achha, describe what is observed at the cathode. Achha, at the cathode we were basically forming our lead, and when we're forming our lead, that means Achha, when they've asked about the observation, we don't have to write that we formed lead, we just have to write what we observe. So we're going to see that a gray solid deposited on the cathode. Deposited. Okay? Whenever they they ask about the observations, always remember, whenever the examiner asks about the observation, you have to write 2 things. One is the color, and second is your state, the physical state, or the state, the physical state. In this as well, in the marking scheme, the marks were for gray and solid. Gray is basically your color and solid is your physical state. ठीक है, अगर ये liquid होता तो फिर आप लिखते gray liquid, अगर ये कोई और color होता फिर आप color और लिखते. So that you know, you got to be careful about the color and the state symbol when you're writing about the observation. ठीक है, you don't have to write about lead, you have to write what you observe. Let's move on. Chemical reactions can involve transfer of thermal energy. ठीक है, state the term used for the transfer of thermal energy during a reaction. That's basically your enthalpy change for the reaction. ठीक है, you should know it's clearly stated in the syllabus that enthalpy change is your transfer of thermal energy. ठीक है, during a reaction. Tetrachloromethane gas CCl4 reacts with steam as shown. This is the reaction. The reaction is reversible. The forward reaction is exothermic. Actually, when they tell us about the forward reaction is exothermic, you can simply make an arrow, write exo. And when you know the forward reaction is exothermic, that automatically tells you that the backward reaction is going to be endothermic. ठीक है, forward exo है तो backward endo है, अगर forward endo है तो backward exo है. ठीक है, that's understood. अच्छा, state what happens if anything to the rate of the forward reaction if the concentration of CCl4 is increased? Explain nuance in terms of the collision theory. Asha, now if you're increasing the concentration of your reactants, what's going to happen? Okay, in an equilibrium, basically equilibrium tries to balance out everything you do. So if you're going to increase the concentration of the reactants in order to decrease it, equilibrium is going to form more of the product. Okay, whatever you do, equilibrium is going to try to reverse it. Okay, if you increase the temperature, equilibrium is going to move towards the endo side to decrease it. Endo means temperature will be absorbed. So if you increase the concentration of your reactants, the equilibrium is going to move towards the forward side. Why? To basically is going to move towards the forward side to to lower down the concentration, to reverse it. Asha, now what they're asking about is not the position of the equilibrium. That is to be kept in mind. Okay, that was what I explained to you about the equilibrium. They're asking about, if anything, to the rate of the forward reaction. Okay, always remember that increasing concentration will increase the rate. You don't have to write that the equilibrium shifts forward. That is not to be written in this question. That would be different if they asked you about state if anything happens to the position of equilibrium, but they have asked about the rate. So increasing the concentration will increase the rate. So you're going to write that rate increases. And why rate increases? Because look, okay, if you have this container and it has 2 particles of CCl4, the collisions are going to be less. But if you increase the concentration of CCl4 in the same particles, in the same container, same volume, you're now going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 particles. Obviously, in which you have 10 particles, there are going to be more collisions. Hence, the rate increases. In which you have 2 particles, less collisions. So increasing concentration means that you have more particles in the same volume. You have more particles per unit volume. So rate increases as more particles per unit volume. And second thing they've asked us is about explaining terms of the collision theory. So we got to include the collision theory as well. Hence, greater frequency of effective collisions. Forming forming product at a faster rate. Okay, product at a faster rate. Okay, that's the same thing that the rate increases. Acha, state what happens अब देखें वही वाली बात होगी. First they asked about the rate and now they've asked about the position of the equilibrium. These two are different things. Never confuse yourself between the rate and the position of the equilibrium. ठीक है, position of the equilibrium move forward or backward and rate increases or decreases. ठीक है, rate ये नहीं हो सकता कि rate moves forward or backward. ठीक है, position of the equilibrium, if anything, when the pressure is increased. Pressure का effect is basically on the moles. It depends on the moles. Now let's calculate out the moles. इस side पे the moles you have to only check for the gases. ठीक है, इस side पे there's 1 mole over here and 2 moles over here. So total of 3 moles on this side and 1 mole over here and 4 mole over here. अच्छा, सिर्फ be careful, you only take the moles for gases. I'm taking moles because these all are gases. अगर ये solid होता तो मैं इसके moles नहीं count करती, because pressure only affects gases. ठीक है, pressure only affects gases. ठीक है, you got to be careful about this. ठीक है, यहाँ पे total 3 हो गए, यहाँ पे total 1 plus 4 is going to make it 5 moles. अच्छा, when you increase the pressure, increasing pressure shifts equilibrium to the side with less moles. ठीक है, I'm going to write it over here. Increasing pressure shifts equilibrium to side with less moles, and vice versa. If you decrease the temperature, it's going to shift the equilibrium towards the side with more moles. तो अभी तो the temperature increase हो रहा है, the equilibrium will shift towards the forward side. ठीक है, so I'm going to write it shifts forward towards product side. अच्छा प्रेशर इंक्रीज हुए तो एक सेकेंड सॉरी बैकवर्ड होगा ना, कम मोल्स की तरफ होगा. आई एम सो सॉरी. इट्स बैकवर्ड्स टुवर्ड्स द रिएक्टेंट साइड नॉट फॉरवर्ड. इंक्रीज हुआ ना, आई कंफ्यूज्ड इट. इंक्रीज हुआ तो बैकवर्ड होगा जहाँ पे हमारे लेस मोल्स हैं. जब इंक्रीज होता है तो लेस मोल्स की तरफ होता है, और जब डिक्रीज होता है तो मोर मोल्स की तरफ होता है. सो इट शिफ्ट्स बैकवर्ड्स towards reactant side as what are we gonna say, that as less moles of gases on the reactant side. Why I've written this? Because इन्होंने कहा था explain भी करना है. Gases on the reactant side, or you could write that more moles of gases on the product side. ठीक है. अच्छा, let's move on. Figure 5.1 shows an incomplete reaction pathway diagram for the forward reaction. ठीक है. This is your, basically these are the reactants. ठीक है, and these are your products, and that's the reaction pathway. अच्छा, let's see the question on figure 5.1 and say the formulae of the reactants and the products. अच्छा, formulae लिखने हैं, मतलब ये और ये लिखना है. अच्छा, ये हमारे reactants हैं, ये तो सबको पता है, and ये हमारे products हैं. तो let's just quickly write them down. इधर reactants आएंगे तो reactants हैं CCl4 gas plus 2H2O gas. These are the reactants, and products are basically CO2 gas plus 4HCl gas. These are the reactants and products. Achha, draw an arrow labeled EA to show the activation energy. Activation energy is from the reactants to the top of the peak. Okay, so this is your activation energy, which is EA from the reactant. ये हमारे reactants हैं और ये हमारे products हैं. तो ये reactants से लेके top तक होएगा. Draw an arrow labeled delta H, ठीक है, enthalpy change to show the transfer of energy for the reaction. देखें, ये एक exothermic reaction है. How do I know ये एक exo है? Because reactants के पास ज़्यादा है, products के पास less energy है. So it's going to be an exothermic reaction. So in the exo, it's downwards like this from the reactants to the product. So the arrow for the enthalpy change is going to be downwards from the, basically from the reactants towards the products, and label it with delta H. Done. Define the term activation energy. ठीक है, activation energy is the simply minimum amount of energy. That's easy, you should learn it. Minimum amount of energy that the colliding particles must have. जब भी define आए ना तो learn the definitions from the syllabus. That's highly recommended. That the colliding particles must have in order to react. अगर activation नहीं होगी, activation energy नहीं होगी, they're not going to react. ठीक है, so they must have the activation energy. State one way in which the activation energy of a reaction can be changed. अच्छा, many of you in this question might think that temperature, ठीक है, temperature might change the activation energy, but that's wrong. Temperature increasing means that more particles have activation energy, but increasing temperature means that more particles have activation energy. It will not change the amount. अगर activation energy for instance 320 basically 320 kilojoules per mole है, ठीक है, इतनी activation energy है, और simply to make it easy it's simply 320 joules, ठीक है, that is easier I guess for you to digest. अच्छा, अगर 320 joules है for the activation energy, तो अगर आप temperature को increase करेंगे तो activation energy तो same ही रहेगी, but what will happen is कि more particles will have this, इतनी energy ज़्यादा particles के पास आ जाएगी. पहले 5 particles के पास इतनी energy थी, अब 10 के पास आ जाएगी, तो reaction fast हो जाएगा. but activation energy की amount को कोई फ़र्क नहीं पड़ेगा, वो 320 की 320 रहेगी. but one way in which you can decrease this amount, इस amount को decrease करने के लिए you can add a catalyst. So the answer is going to be, state one way activation energy can be changed by adding catalyst. And what's the effect? It decreases EA. EA is your activation energy, ठीक है, फिर वो amount को less कर देगा, but temperature will have no effect. Actually, let's move on. The equation for the reaction between tetrachloromethane gas and steam can be represented as shown in figure 5.2. ठीक है, this is basically equation. अच्छा, table 5.1 shows the bond energies for CCl, for HO, and for C double bonded O. Use the bond energies in table 5.1 and the delta H values for the reaction, ठीक है, to calculate the HCl bond energy. Use the following steps. अच्छा, सबसे पहले let's follow the steps. Simple and easy. Calculate the energy needed to break the bonds in the reactants. अच्छा, reactants में हमें ये वाला bond break करना है, ये वाला bond break करना है, ये वाला, ये वाला, ये वाला, ये वाला, ये वाला, ये वाला. So basically 4 हमें bonds break करने हैं. देखें 1 2 3 4 of CCl. ठीक है, 4 bonds of CCl. For one bond we need 340 basically joules of energy. So for breaking 4 bonds we'll need 4 into 340. That's going to be 4 into 340 will give you 1360. और ये total reactants यहाँ पे arrow है, तो these are also reactants. ये OH वाले water is also the reactant. So basically इसके लिए भी हमें OH के 4 bonds हैं. This is 1, this is 2, this is 3, 4. एक OH के लिए 460 चाहिए. So basically 4 into 460. अच्छा, 4 into 460 will give you 1840. अब हम ये देखें टोटल एनर्जी इसको इतनी चाहिए दोनों रिएक्टेंट्स हैं, तो टोटल एनर्जी फॉर द रिएक्टेंट्स इज़ गोना बी 1360 प्लस 1840 प्लस 1360 will give you 3200. ठीक है, so this is basically your it is going to be your answer for. So just copy from here and paste it down over here. This is going to be your answer. Asha, this is going to be your answer. I don't know why it's not working. ठीक है, 3200 kilojoules is going to be your answer. ठीक है, let's move on. अच्छा, calculate the energy released when the bonds in carbon dioxide form. ठीक है, अब energy release होगी. How many bonds do we have? We basically have 2 of these carbon oxygen double bonds. ठीक है, एक को चाहिए 805. So for 2 ये 2 है, so it's going to be basically 2 into 805, which is going to be 2 into 805, that will give 1610. Asha, so that's going to be 1610. Asha, calculate the HCl bond energy. Let's calculate the HCl bond energy. अब total energy जो है वो -130 किलोजूल एंथैल्पी चेंज. ठीक है, ये हमें पता है. So हमें पता है कि हमारा energy for the absorbed in the reactants minus released when the products were formed is equals to your total enthalpy. अच्छा, अब absorbed total reactants में कितनी हुई थी हमने calculate की थी. It was 3200. So 3200 minus हमारी कितनी released हुई है. एक तो 1610 हमारा product है उसमें release हुई है, और एक ये 4 HCl के bonds में release हुई है. ठीक है, so we're gonna write that एक हमारा 1610 है minus 1610 और minus हमारे जो HCl के bonds में हुई है 4. Let's call the bond energy x because we don't have its value, is going to give me a total enthalpy change of this. This is -130. Simple equation है, just 13,200 minus 1610. Move this to the side, it will become plus 130 equals to 4x. In order to get the value of x, you just add 3200 minus 1610 plus 130. इधर ये इससे multiply हो रहा है तो जाके divide हो जाएगा, divided by 4, and x will come. Just find it out. Do it on your calculator. 1300 minus 1610 minus इधर जाके माइनस होना था ना, अच्छा नहीं इधर जाके प्लस ही होना था, plus 130 will give you 1720, and when you divide 1720 by 4, that's going to give you 430. So your answer is going to be 430. That was simple and easy. Let's move on. A homologous series is a family of organic compounds whose members have similar chemical properties, state to characteristics that is same for all members of the homologous series. You cannot write physical properties over here because there's a trend in physical properties. Down the group, the physical properties change. Okay? For example, an example is the melting boiling points. They increase. Okay? Decane is going to have a higher melting and boiling point. Okay? अगर हम अपना मीथेन लेते हैं and you take your decane, so decane is going to have a higher melting and boiling point. Okay? So you cannot write physical properties because they are not the same. They change. So what's the same? The general formula is same. The general formula for methane and decane is going to be same. And moreover, if you take alkenes or the alcohol functional groups, all members have the same functional group. Okay? So these two things are going to remain the same. Otherwise things change. ठीक है? Down the group some things differ, लेकिन physical properties differ हो जाती हैं. Chemical properties कुछ ज़्यादा combustible होते हैं, कुछ कम combustible होते हैं. So there are different changes, but these two always remain the same. In terms of structure, state how one member of a homologous series differs from the next member. Always remember that every member of the homologous series differs by one methyl unit, which is CH2. CH2, यहाँ पे extension bonds are important. So one methyl unit. It can be written as one methyl unit. But what they were asking for in terms of structure. Structure का मतलब है ये structure बना के दिखाने CH2 का. This is one methyl unit. मतलब इसका क्या है कि देखें, अगर आपके पास मीथेन है ना और आपके पास अगला ईथेन है, तो मीथेन और ईथेन में जो डिफरेंस है ना वो CH2 का होगा. इसमें C एक कार्बन ज़्यादा होगा, 2 हाइड्रोजन. अगला आपके पास है प्रोपेन. So the difference between ethane and propane is going to be of 1 methyl unit. अगला आपके पास होगा butane और फिर अगला होगा pentane. So all will have a difference of 1 ethyl unit, and this is for every homologous series. ठीक है? A, B, C are organic compounds. A has the molecular formula C12H24. B has the name tetradecane. Decane. Ane basically tells you that's going to be, don't be intimidated by tetra and everything. Decane just simply tells you that it's going to be an alkane. अगर आप देखें in the first one there are 12 carbons and 24 hydrogens, so that's going to be an alkene. Why I know it's an alkene? Because hydrogen are double. CnH2n is basically a formula, general formula for alkenes, and that's going to be an alkene because hydrogen are double. In alkenes you have double hydrogen than carbon. C has 3 carbon atoms and is in the homologous series with the general formula this. This is, I know it's C double bond OH. It's obviously, it has 3 carbons. It's going to be a propanoic acid. Why do I know it's a propanoic acid? First, it has 3 carbons, so it's going to be a propanoic. It's going to be a propan. And why it's an acid? Because this is the general formula. Okay? Name the homologous series each compound belongs to. A belongs to an alkene. B belongs to an alkane. I just figured it out right now. And C belongs to carboxylic acid. Okay? Everything is important. You cannot write simply carboxylic. You got to write the acid part as well. Okay? Name C and draw its displaced formula. So C was basically your propanoic acid. How did you figure it out? You figure it out simply by reading that it has 3 carbons. The displayed formula is going to be 3 carbons, 1, 2, 3 with a double bond OH. ठीक है, ये हमारा basically C double bond O वाला group है. This is basically the functional group, and then you draw all the remaining hydrogens to fill up. ठीक है, just don't exceed के carbon को आप ज़्यादा hydrogen दे दो. For like the total valency of a carbon is 4, so make sure that you have 4 bonds with every carbon. ठीक है, जैसे अब यहाँ पे एक hydrogen नहीं आएगा. क्यों नहीं आएगा? Because carbon ने पहले 1, 2, 3, 4 पूरे कर लिए. So no hydrogen over here. Just make sure about these things. ठीक है, और यहाँ पे भी कोई hydrogens इस वाले part पे भी नहीं आएंगे because oxygen की valency 2 की है, that's being fulfilled. Hydrogen की 1 की है, everything is in balance. ठीक है, let's move on. Amino acids are homologous series with each member, ठीक है, has the general structure shown in figure 6.1. The R side chain contains carbon and hydrogen atoms only. ठीक है, अब वो हमें कह रहे हैं कि this side of the chain, this R side, this is basically some carbon atoms and hydrogen atoms, and we don't know what are these. ठीक है, हमें सिर्फ इतना general हमें सिर्फ इतना फार्मूला आता है. The rest, this R part, we don't know, but we know that there are going to be some hydrogen and some hydrogen and some carbon atoms over here. ठीक है. अच्छा, amino acid has the relative molecular mass of 103. ठीक है. मतलब इस टोटल का जो mass होएगा वो basically होएगा 103. ठीक है. Deduce the formula of the R side chain in this amino acid show you working. अच्छा, सबसे पहले तो हम R साइड के लिए बाकी साइड का तो फार्मूला निकाल के उसको टोटल में से माइनस कर सकते हैं ना. ठीक है. लेट्स फाइंड आउट द फार्मूला फॉर अदर थिंग्स. हाइड्रोजन यहाँ से स्टार्ट करते हैं. हाइड्रोजन का होगा मास 1. फिर हम अपना नाइट्रोजन का लेते हैं +14. फिर दोबारा हाइड्रोजन +1. फिर कार्बन दैट्स गोना बी +12. फिर उसके बाद कार्बन के बाद एक और कार्बन +12. फिर एक और हाइड्रोजन +1. फिर एक oxygen that's going to be 16. Then we have one oxygen again 16 plus then we have hydrogen again 1. So let's calculate out this mass on a calculator for everything except R, which is going to be 1 plus 14 plus 1 plus 12 plus 12 plus 1 plus 16 plus 16 plus 1, and that is giving 70. Let's calculate it out again because we got to be sure about this, because by using this we have to solve the next parts as well. Okay, so in order to reduce and minimize errors, try to repeat the process. $74. Okay, 12 into 2 plus 16 into 2 plus 14 plus 1 2 3 4, that is going to be 74. ठीक है. अच्छा चलो ठीक है. now we're going to subtract. अच्छा 74 जो है इस पूरी चीज़ का है. this whole thing is 74. we have to calculate the mass for R. from the total mass, if we subtract this mass, we can get the mass for R. ठीक है. we have to write down the formula, but ठीक है, for formula first we need to calculate the mass. So 74, we're going to subtract it from 103, and 103 minus 74, that's going to give you 29. अच्छा, अब 29 हमें we have to formulate something that has, because our side contains only carbon and hydrogen, we need to formulate something that is only carbon and hydrogen. ठीक है. कार्बन एंड हाइड्रोजन, एंड इट शुड हैव अ मास ऑफ 29. अच्छा, अगर हम एक कार्बन यूज़ करते हैं तो हमारे पास 12 होगा. अगर हम 2 कार्बन यूज़ करते हैं तो 24 होगा, और 3 कार्बन यूज़ करते हैं 36 होगा. तो 36 तो हम यूज़ नहीं कर सकते क्योंकि टोटल 29 है. सो ऑब्वियसली वी हैव टू यूज़ 2 कार्बन्स. तो C2, और बाकी 29 में से हमने 24 जो है कार्बन ले लिया. माइनस करते हैं 29 माइनस 24 विल गिव यू 5. तो मतलब बाकी 5 जो होंगे हाइड्रोजन होंगे. तो हमने रिड्यूस कर लिया C2H5. ठीक है. लेट मी रिपीट व्हाट आई जस्ट सेड वाज के दैट व्हाट यू डू इज़ यू सॉ दैट एक कार्बन होगा तो 12 होंगे, 2 कार्बन होगा तो 24 होंगे, एंड इफ यू गोना टेक 3 कार्बन इट्स गोना बी 36. ऑब्वियसली यू गॉट टू हैव अ मास ऑफ 29, सो इट कैन नॉट बी 3 कार्बन्स. सो द हाइस्ट नंबर ऑफ कार्बन्स पॉसिबल इज 24. ठीक है. सो यू टेक 24 you take 2 carbons, that's going to have a mass of 24. So now out of 29, 24 is the mass of your carbons. You subtract it, you get 5. 5 is obviously going to be the mass of the hydrogen. One hydrogen has a mass of 1, so 5 are going to make up to 5. So it's going to be C2 and H5. Okay, I hope that was easy. Let's move on. State the name given to natural polyamides from amino acids as monomers. You should know that amino acids as monomers are used to form proteins. Okay. And with that we come to an end of our paper. I hope you liked the video. If you do, subscribe to the channel, and that's going to mean a lot. Thanks for watching. Bye bye.